Hello everyone. Today we are going to present our Group Engineering Designs Challenge on the course ENGR 1711. For this Group Engineering Design Challenge, our group decided to work with one of the 8 real life challenges that people with an impairment face every day that needs to be solved, the wheelchair bed system. Let's get started.
Worldwide, around 1% of the population requires the use of a wheelchair. In Australia, 4.3 million people have a disability. Of those, approximately 4.4% require the use of a wheelchair. One reason for people using a wheelchair is a genetic disorder called Becker muscular dystrophy, or BMD. This is a predominantly male genetic disorder that affects 1.6 per 100,000 people worldwide. It's a milder form of muscular dystrophy that primarily affects the hips, thighs, and shoulder muscles, so reaching around the wheelchair to access belongings can be difficult. Symptoms will progress as they age, with some requiring a wheelchair as early as their 20s and others not needing wheelchair assistance their whole lives, depending on severity of symptoms. Most wheelchair users will opt to use either specifically designed wheelchair bags or use clip on hooks when going out. Many companies manufacture bags in different sizes that can be attached to the sides or back of the wheelchair. These range between $20 to $150, with the most common price being $50. A common alternative to this is bag hooks. They consist of a closed hook with a Velcro strap that can wrap around any stable part of the wheelchair. These are available online and in many mobility stores for $5 to $10 to the consumer. While these allow people to attach bags with ease, it still doesn't allow for anything without a handle to be attached. And for people with loss of muscle strength, it can be difficult to open the hook to add or remove bags with ease. With limited space on the wheelchair, it can be difficult for people to find a safe and reliable place to put their belongings when going out. If bags aren't properly attached, they could fall out, making it difficult or outright impossible to pick items back up. While these bags are useful, people will have to plan what they'll be getting throughout the day in advance. It also doesn't give them any space to put grocery bags or other items that may not fit in these bags. So the problem we wanted to look at was to design an alternative way of attaching bags and other objects to the wheelchair for people who live with BMD.
Design requirements. When considering different design requirements, the group thought to prioritize these main points in the final design: safety, ergonomic, cheap, accessible bag storage, and can store multiple items, and to keep the bag always in sight. Safety is number one, and the group wanted to make sure that there were no hazards in the design or any way anyone else could get hurt in the process of using the product. Ergonomic to keep the wheelchair effective and efficient, making sure it's easy access and the least amount of effort possible to use while using the storage design. We would like to keep the design cheap also, so it can be quick and easy production and quick and easy distribution. The design would also include storage system to be easy accessible while seated in the wheelchair, also making sure it can store multiple items while keeping the bag in sight to eliminate the possibility of unnoticed thefts.
As shown, a quick sketch was made for our rough design where the full layout is shown, along with the parts list. This was made to get rough estimates for dimensions to be later used in the creation of the CAD model. This model that we have designed is just a rough configuration of an idea that we came up during our brainstorming process. This is a basic preview of what is essentially a bag trailer for a wheelchair. It was designed to carry heavier and larger bags. The main setback with using this design is that there isn't enough room for a person to push the wheelchair comfortably, which doesn't sit well with our design challenge.
For the design specifications of our concept, our main objective is to extend the capacity of the bed system. Since the design of the wheelchair itself is not in our consideration, let's focus on the bed system. The total length of the bed system is 1,300 mm with a width of 650 mm. The general width of an opened wheelchair is usually around 640 mm to 660 mm. So, the bed system can fit into almost all wheelchairs with ease. In terms of storing things, the bed system is working perfectly. But in terms of ergonomics, I guess there is still a long way to achieve perfectness. Yes, the bed system is plain, simple, and easy to understand. I'm sure the design is in accordance with the principle of universal design if it's not designed for a wheelchair user and is not moving. Since all the luggage is stored on the back of the wheelchair, it's difficult for people with low mobility and a lack of flexible posture to reach to the bag system, making it almost impossible to actually use the bag system without others helping. Also, the tolerance for error is relatively low. It's because while traveling in a forward direction, there will be a chance of leaking the object without users' awareness.
Evaluation of alternative designs. The group's first design resembled that to an average hand trolley, which was easy for coupling onto the wheelchair and met some design requirements the group came up with. The group thought that the hand trolley design would be safe for the user, cheap, and would be easily store multiple items, although it also failed to meet many other requirements. This would include ergonomic, accessible bag storage, and the stored items wouldn't stay in vision, which makes the design prone for item theft. It could also be potentially hazardous to nearby pedestrians or nearby observers if the user is not careful with the big load attached to the wheelchair. To access the stored items, you'd have to either turn all the way around to reach the hand trolley while in the chair or get out of the wheelchair completely, which doesn't meet ergonomic and easy access design requirements at all. Therefore, the group thought of coming up with another design that would meet all the design requirements.
For our alternative design specification, we are now focusing on the area where the users can actually reach, which are the armrest section. The general length of the armrest bar for adults is around 300 millimeters, and the general area of the base is 35 millimeters times 35 millimeters. If we want to create a bag system that can fit into almost every armrest bar in the wheelchair, the base needs to be big enough to let the bar pass through. And the length of the bag system shouldn't be too long because if it suppresses the armrest bar, the system will lose support. So we decided the total length of the bag system will be 250 millimeters.
In order to test this design, the maximum load capacity was found by applying force directly onto the hooks until failure. This was used to determine the limits of the design to ensure the user does not overload the hooks. This was simulated in Autodesk Inventor and was found to withstand 1 kilogram of load for each hook. Here is the exploder view and the full assembly of our product. It features an upper and lower plate that are fastened with 12 ISO 4026 screws. This product is easy to assemble as it only requires the lower and upper plates to be attached to the armrest of the wheelchair and fastened with the 12 screws. The upper and lower plate are similar components, however the upper plate is equipped with 5 hooks that allow the user to carry items in bags. The hooks are designed to rest against the armrest of the chair to allow for more support of the load being carried. The material used to create this product is aluminium, as this is a strong, lightweight, and cheap material to use. This specific design can be attached to a square armrest with the dimensions of 30 by 30 millimeters. However, the product can be scaled to accommodate other chairs. The hooks are placed 48 millimeters apart, center to center, as this allows for even distribution of the load. The product is 250 millimeters in length, 50 millimeters wide, and has a height of 36 millimeters, allowing for a low profile of the chair. All corners and edges of this design are rounded to ensure user safety.
This is the end of our presentation. Thank you.